Check this out, full auto-completion for all my environmental variables, type safety throughout my codebase, and these beautiful detailed error messages that tell me exactly what's missing before my app even starts. No more runtime crashes, no more hunting through logs, and no more TypeScript errors. This is what working with environmental variables should feel like. But how did I get here? If you've been writing TypeScript apps for any length of time, you know environmental variables are unpredictable by nature. They can be anything or nothing at all. Now, in the next few minutes, I'll show you the surprisingly simple 3-steps process that transformed my development experience from constant frustration to this level of confidence. And the best part, it scales effortlessly whether you have 3 variables or 300. Now here's the problem. In TypeScript, every environmental variable is typed as a union of string and undefined. Now this duality creates immediate friction in strictly typed code bases. Consider this innocent looking example where we load some environmental variables. First we import the .env module, then configure the module to load your .env file, and then we log the env entries to the console. You can see I have my environmental variables logged to the console. Simple enough, right? We load our variables and log them to the console. But looking closer reveals a fundamental problem that cascades through our application. When we try to assign environment variables to string type constant, TypeScript immediately raises red flags. Now the compiler complains because these variables might be undefined. So how do developers typically address this issue? Let's examine 2 common approaches, each with their own trade-offs. Now on a lazy day, you might reach for the non-null assertion operator, the TypeScript escape hatch that lets us say, hey, trust me, this will exist. So you just append the non-null assertion to the variables and the error magically goes away. Now this solution is tempting but dangerous. It silences TypeScript without adding any runtime safety. What happens when we deploy to production and forget to set these variables? Instead of getting a clear error, you end up with some cryptic failures somewhere else in your application, possibly only in certain environments or under specific conditions. Alright, now a more careful approach would be to use type narrowing to check for undefined values before attempting to use them. This involves checking to make sure that each environmental variable is not undefined. If any is undefined, we throw an error. With that, we don't get any more errors and our code still works as expected. We can also test missing variables by removing one of the environmental variables, and we'll get clear errors when variables are missing. Now, while this approach works, it becomes tedious and difficult to maintain as your project grows. Imagine adding 15 environmental variables, you'd have 15 separate checks cluttering your code base. Each new variable requires another conditional, creating a maintenance nightmare that completely violates the dry principle. So is there a way to achieve type safety for environmental variables without sacrificing maintainability? Absolutely. Let me show you a straightforward solution in just 3 steps that will transform how you work with environmental variables. You may have guessed that the foundation of our approach is based on a schema validation library, and Zod has become the community favorite for TypeScript for validation, but alternatives like Joy, Yop, or IOTS work similarly. So start by adding your chosen library to your project. This simple utility will transform how we handle environmental variables, bringing both compile time and runtime safety to what was previously a fragile part of our code base. Now the next step would be to create a central configuration file where you define a schema for your environmental variables. Start with importing Zod and .env module in this project, then load the environmental variables. Now define your schema. This will serve as your single source of truth. Set the secret key as string and the database URL as string as well. Now to validate your environmental variables, pass it to the schema.parse function. Now this schema is going to serve multiple purposes simultaneously. It documents which environmental variables our application requires, validates them at runtime, and provides TypeScript with the type information it needs. The parse function will throw a detailed error if any required variables are missing, preventing your application from starting with an incomplete configuration. Alright, now the third step would be to actually go ahead and use these environmental variables. And all we have to do is anywhere in our code base, import the config file, then access the variables with full auto-completion and type safety. Now I want you to pause for a moment and notice what's missing here. We have zero type assertion, we have zero conditionals, we don't have any redundant checks. Now your editor even provides auto-completion for available variables. This approach is not just convenient, it scales effortlessly. Adding a new environmental variable means updating just one schema definition instead of adding scattered conditionals throughout your code. Also, I can confirm that this validation works by removing an environmental variable, and there goes a neat description of what I'm doing wrong. Now, the true power of schema validation emerges when you need more than simple string values. Zod lets you transform and validate environmental variables with specific format or constraints. For example, we can convert string to number, we can restrict to a specific set of values, we can pass as boolean, and we can create a custom validation and custom message. These examples don't just check for existence, they ensure your variables have the correct format, range, and type for your application's needs. Your configuration becomes a self-documenting contract that validates itself at runtime. That's how you validate environmental variables. Thank you for hanging out, and I hope you enjoyed this video. I'll see you in the next one.